A model for the length of daylight in hours in Philadelphia on the teeth day of the year is L of t, which is equal to 12 plus 2.8 times the sine of 2 pi over 365 times t minus 80. We want to use this model to compare how the number of hours of daylight is increasing in Philadelphia on June 5th and June 15th. Assume there are 365 days in a year. Round your answers to 4 decimal places. So the first thing we're going to do is we're going to just write out our function. So we have L of t, which is equal to 12 plus 2.8 times the sine of 2 pi over 365 times t minus 80. Okay, so now we're going to find the derivative of this function. So to find the derivative of this function, we know that the derivative of 12 is going to give us 0. And now this function, we're going to use the chain rule. So the outside function is going to be 2.8 sine. So we're going to take the derivative of that, and that's going to become 2.8 times the cosine of 2 pi over 365 times t minus 80. And then using the chain rule, we're going to find the derivative of what's inside, which is 2 pi over 365 t minus 80. Okay, so we end up getting 0 plus, so we have 2.8 times the cosine of 2 pi over 365 times t minus 80. So if I distributed this, okay, the second term is going to be a constant. So when we take a derivative of the constant, it's going to be 0. So technically this is going to be 2 pi over 365 t minus 2 times 80, which is 160 pi over 365. And so therefore this is going to give us 0. And the derivative of 2 pi over 365t is going to be 2 pi over 365. So therefore this is going to represent the derivative of that function. Now in step number 3, we want to be able to compare the number of hours of daylight that's increasing on June 5th and June 15th. So if we take a look at on June 5th, the amount of days, well, t is going to represent 156. So what we're going to do now is we're going to find L prime of 156 and then plug it into the formula. So we have 2.8 times the cosine of 2 pi over 365 times 156 minus 80 times 2 pi over 365. And then we're going to round that to, it says 4 decimal places. So let's go ahead and do that. So we're going to take 2.8 times the cosine, and then we're going to start with a parenthesis. So we're going to say parenthesis and then 2 pi divided by 365, close the parenthesis, open another parenthesis, 156 minus 80, close a parenthesis again, and then we're going to multiply that by parenthesis 2 pi divided by 365, close the parenthesis, and we get round to 4 decimal places 0.0125. So we get 0.0125. Okay, and so now that is how many hours per day. Okay, now on June 15th, we know that T is going to equal 166. So we're going to find L prime of 166, which is going to equal 2.8 times the cosine of 2 pi over 365 times 166 minus 80 times 2 pi over 365, and then we're going to round that to 4 decimal places. So let's go ahead and do that. So on our calculator, if you have a calculator like this, all we're going to do is press enter here, and then we're going to change this 156 here to be 166. So we're going to put a 6 there, and then we're going to press enter. And then if we round that to 4 decimal places, we get 0.044. So that's 0.0044. And again, that's hours per day. And so here we can compare. We can see what happens on June 5th. We get 0.0125 hours per day. And then on June 15th, it's 0.0044 hours per day.